So this is the fourth and final video on the practice final. It's the fourth page. And let's take a look at number 27. This one's fun. It says, use the relation shown in the table to create a function form equation, and they want it in f of x form. Okay? F of x is the same thing as y. So there's many ways, or several ways, of coming up with the equation that produces this x and y table, or that produces this input-output table. So I'm going to explain both ways, or at least two ways. Let's start with the most recent thing that we learned earlier this week, which was the a sub nth rule. Now think about this, guys. X's are your inputs, right? They're your domain values. So in a sense, you could think of this as a sub 1. Your first term is 0. Your second term is 2. Your third term is 4. Your fourth term is 6. Does that make sense? Your fifth term is 8. So if you wanted to, you could change it to a sequence. You could change it to a sequence and say 0 is my first term, 2, 4, 6, 8. There's my arithmetic sequence. Why am I saying arithmetic already? Because it has a what? Common difference. And what is the common difference right there? What's the common difference? It's 2, right? Your a sub 1 term was 0. Your second term is 2. Your third term is 4. Your fourth term is 6, and so on, right? Okay, so your common difference is 2. Because if you do 8 take away 6, that's 2, or 2 take away 0, that's 2, or 4 take away 2, that's 2. So there's a common difference. It's arithmetic. And we do know the a sub nth rule for an arithmetic sequence. It's a sub n equals a sub 1 plus parenthesis n minus 1 times a common difference d, right? Now, so if we do set it up this way, we know that the a sub nth rule is a sub 1, which is what? What's a sub 1? 0, right? So 0, and then plus parenthesis n minus 1 times a common difference d. And what's our common difference? 2. So you put a 2 right here, and you know you're multiplying. So in order to write this as a function form equation, you want to simplify it, right? So 2 times n is 2n, and 2 times negative 1 is negative 2, and the plus 0 in the front disappears because adding 0 doesn't change anything. So what we really have is a sub n equals 2n minus 2, and that's really a function form equation. But if you want it in terms of f of x, if you want it to look like f of x instead of a sub n, just replace the a sub n with f of x equals 2x minus 2. Now, what that means is, if I do plug in 1 for my x right here, what's 2 times 1? 2 minus 2? 0. You see how you get the output 0? If I do plug in 4 into my x value right there, 2 times 4 is what? 8 minus 2? 6. So when you plug in 4, you really do get 6, right? Now, let's say you don't like this general rule. Okay, if you don't like the general rule, there's other ways of doing it. Okay, when you look at this XY table, you do notice that there's a common difference, right? The inputs are in order, 1, 2, 3, 4, 5. There's a common difference, 2, 4, 6, 8. There's a common difference of 2. So one thing to do is to realize that it is a perfect line, right? If you were to graph it, it would be a line. So you know that you could write an equation in y equals mx plus b form. All right, so there's a second option. If you understand this method, go for it. I like this method actually a lot better than this other one. But if you don't like this new method of finding the general rule of an arithmetic sequence, if you want to actually just find the equation of the line in terms of y equals mx plus b, y equals mx plus b, well, you need two things. What are the two things you need to write an equation of y equals mx plus b? An m and a b. So let's say I wanted to find an m. Well, I could use my slope formula if I just saw two coordinates, 2 points. But we do have a bunch of points here, guys. We have the coordinate 1, 0. We have the coordinate 2, 2. We have the coordinate 3, 4, 4, 6, 5, 8. So you could pick any of those coordinates and use the formula where you have y2 minus y1, x2 minus x1. And let's call the top point x1, y1. So x1, y1, and we'll call the second one x2, y2. So when you plug it in, and you put the subtractions first, when you go y2, that's 2, minus y1, that's 0, and you go x2, which is 2, minus x1, which is 1, you're going to end up with the slope 2 over 1, which is just 2. Yay? So that's your slope. Your m value is 2. Now let's find the b value. Then you could go back to y equals mx plus b, and you could actually plug in the 2 right into the m because 2 is m. And you could also plug in any coordinate you want into the x value and y value. So let's say you wanted to use the 5 and the 8. You could plug in the 8 for y and the 5 for x, and then you'd have this new equation that would be 8 equals 2 for m times x, which is 5, plus b. And you could solve for b. You'd have 8 equals 10 plus b. And if you subtract 10 on both sides, you end up with b equals negative 2. Get it? So now that you know the m and the b, you know to write your equation. So your m is 2, your b is negative 2. What's your equation of y equals mx plus b? Y equals 2x plus a negative 2. Yay? As you can see, it's the same equation that we got down here. Y equals 2x minus 2. As a matter of fact, let me write it. Y equals 2x minus 2. But then again, it says in f of x form. So all you have to do is replace the y with f of x. Now, it's going to be easier on the final because it's going to be multiple choice. So all of them will be in the form of f of x. But those are two completely different methods on the same problem. You could use the arithmetic sequence general rule, or you could use y equals mx plus b, find the slope, use the point to find the b value, and then you have your equation. Whew, that was a lot for one question. Number 28, write an algebraic expression for 5 times x squared minus 7 times x. So let's just take a piece at a time. 5 times x squared, that's 5 times x squared, minus 7 times x. And that's it. There's your answer. 5x squared minus 7x. There's nothing else to do, nothing else to simplify. That's it. So number 28 is done. That's the algebraic expression. So on number 29, they tell us which of the following is arithmetic. Again, an arithmetic sequence has a common difference. And the way to find that common difference is you take any number and you subtract the number before it. So if I take 7, what's 7 take away 1? 6. So let's see if it's arithmetic. What's 9 take away 7? That's not 6. That's 2. So those differences are different. They're not common. So arithmetic have common differences. It cannot be A. Cannot be A. Okay, how about C? What's 4 take away 2? What's 8 take away 4? See, that's not the same, right? There's no common difference. If 4 take away 2 is 2, then this next one, this one take away this one has to be 2 as well. So if this was a 6, that would have been good, but then that would have changed it over here. So this one does not work either. Does that make sense? And this is a really easy question. It's going to be like this on the final. So how about this one? Let's go with the negative 5 take away a negative 8. What's negative 5 take away a negative 8? Maybe we need to show that work. Negative 5 take away a negative 8. What's that? That is 3. Okay, how about negative 2 minus a negative 5? Negative 2 minus a negative 5. That's also 3. So far it's looking good, right? How about the last one? 1 minus a negative 2. 1 minus a negative 2. That's also 3. So we really do have a common difference. So this is our arithmetic sequence right there. Nothing else to do. Let's move on to number 30. This one's fun. Use the following information. The number of people sitting in each row of a concert form an arithmetic sequence as shown on the table. So there's a concert. Obviously, it's not a sellout crowd on this concert. But let's say the first row, right there, front row seats, there's 35 people in that front row seat, right? And then you go to the second row, there's only 32 people there. And then you go to the third row, there's 29 people there. And then you go to the fourth row, there's 26 people there. So obviously, the further you get from the front row seats, the less people that are in the seats, right? So the question is this, and please pay close attention because there is no question right here. There's a typo on my part. So the question that I want you guys to know when you're watching this video is how many people are in the 10th row? So we want to find out how many people are in the 10th row. Now, we know that this is an arithmetic sequence. What does that mean? That there's a common difference, right? What's the common difference, guys?
3.
Is it 3?
Yes.
Think about this, guys. From 32, take away 35. Remember, to find the D, to find the common difference, you need to take a number and subtract the previous. So I need to take 32 and I need to subtract the previous 35, and that will give me D. So ladies and gentlemen, what is D? It's negative 3. If you say positive 3, unfortunately, all your work's going to be wrong. Okay? So right here, the common difference is negative 3. I mean, think about it. It's actually decreasing by 3, right? So 35, take away 3 is 32. Take away 3 is 29. Take away 3 is 26. That's why the common difference is take away 3, the negative 3. Okay? So once you know that common difference, and also once you know your a sub 1 term, what's the a sub 1 term? What's your first term? 35. Your a sub 1 term is 35. So once you know the a sub 1 is 35 and your difference is negative 3, then you could use the general rule. Let me write down my general rule right here. So a sub n equals a sub 1, we said our first term is 35, plus parenthesis n minus 1 times a common difference d. The common difference d is negative 3. So you're going to put negative 3 in parentheses. So we need to simplify this equation. So let's distribute the negative 3. Negative 3 times n, negative 3n. Negative 3 times negative 1 is positive 3. Bring down the plus, bring down the 35. And we could still continue to simplify that to say that our final general rule is a sub n equals negative 3n plus 38, right? When I combine 35 with 3, that's 38. Ladies and gentlemen, that is our arithmetic general rule. Now, this rule right here will give you any number you want, right? Now, let's say you're not too comfortable with this rule. You probably think, oh, I made a mistake. So if you wanted to verify, you could simply plug in the number 1 and see if you really do get 35. Or you could plug in the number 4 and see if you really do get 26. Just if you want to verify, feel more comfortable with yourself. So let's say I plug in 4. What is negative 3 times 4? That's negative 12. And if I add negative 12 plus 38, I really do get 26, right? So if you plug in 4, you will get 26. Or you can plug in 1. Check it out. Plug in a 1 right here. What's negative 3 times 1? Negative 3. What's negative 3 plus 38? 35. So when you plug in a 1, you really do get 35. So at this point, you should feel comfortable that this is the function machine that creates this list, right? So what are they asking for? Now, you're going to have to write this in on your paper because I forgot to type it in. How many people are in the 10th row? So what I'm really asking for is to find out a sub 10. So I'm saying find out a sub 10. So how would you do that? You actually plug in 10. So you have negative 3 times 10 plus 38. So what's negative 3 times 10? It's negative 30 plus 38. So on the 10th row, guys, how many people are there on the 10th row? 8 people. So on the 10th row, there's only 8 people. Make sense? Now, what if I didn't ask for 10th row? What if I asked for the 11th row? Then you just plug in an 11. It could ask for the 100th row. But at that point, it's going to get to negative people on this one, so I wouldn't do that, right? So we still need 2 more questions. Let's get to those 2 more questions. Ladies and gentlemen, there is, and these, the one we just did and this one right here, they're kind of rare questions because we didn't spend too much time on word problems throughout the semester, and they will pop out on the final. That's why I really want to emphasize these right here. So, Adrian, number 31, it says, explain in a complete sentences your interpretation of this graph. Now, it could be speed and time. Give me any example that would work with speed and time.
Speeding a vehicle.
A vehicle, okay, a car. Now, check this out. What does it mean if you're at time 0? That's where you begin, right? Okay. So let's say as time goes by, what's happening to your speed?
It's
Increasing. And then all of a sudden, stays the same. And then decreases, and it comes to a stop, right? So the interpretation of this graph is, like you said, you want to do an interpretation of a vehicle? Yeah. You were parked, and you started going until you got to like 45 miles per hour, and then you stayed driving 45 miles per hour for a while, and then you got to a stop sign, and then you stopped. That is an interpretation of this graph right here. So you're going to have to actually, on the final, read a couple of sentences, 4 sentences, and pick the one that actually works for the graph. Or I want to give you a sentence on the final, and you're going to have to pick the graph that works for the sentence. Does that make sense? Okay. So that's 31. I would say you're in a car, you're not moving, you start moving, you speed up, you speed up, you speed up, and then you maintain a certain speed, and then after a while of maintaining that speed, you stop. You decrease and stop. Moving on to number 32, the final one. This is an interesting one, especially because it has huge numbers. In the year 2004, Mr. Rubio confiscated 10,000 bags of Takis. By the way, this is made up. This is not real. But, you know, in today's day and age, it's very possible. You guys eat Takis every day. You know how bad it is for you? Okay, let's keep going. In 2004, Mr. Rubio confiscated 10,000 bags of Takis. In the year 2016, Mr. Rubio confiscated 39,760 bags of Takis. What is the rate of change of the number of confiscated bags of Takis? So first of all, let's start with this. Rate of change. Ladies and gentlemen, we need to know, for the final, we need to know that rate of change is slope. Rate of change is slope, okay? So we know slope. We know how to find slope with the slope formula. It's y2 minus y1 over x2 minus x1. Now the problem is we need coordinates, ladies and gentlemen. So are you able to read this information and come up with 2 coordinates?
No.
Now remember, a coordinate is an x and y value. Your x is your input, your y is your output. So give me one coordinate.
2004, 10,000.
That's right. 2004 is your input, the year, and the output's the number of confiscated Takis bags, right? So let's actually write down those 2 coordinates. We said 2004 is the x value, and the y value is 10,000. That's one coordinate. That's x1, y1, x1, y1. Now you want your second coordinate. What's your second coordinate?
2016.
2016 and
35. That's 39.
okay, so 2016 and 39,760. It looks crazy. Without a calculator, it is crazy. But you guys are able to use calculators? So this is x2, y2. So we're going to use those 2 coordinates to find our slope. So the slope is, let's plug in our y2 value. Our y2 value is 39,760. Our y1 value is 10,000. Our x2 value is 2016. Our x1 value is 2004. So when I do the math on a calculator, 39,760 minus 10,000, that equals 29,760. So 29,760. And on the bottom, 2016 minus 2004, that's really a period of 12 years. So that's your slope, but you want to reduce it as much as possible. And this fraction really is a division problem. 29,760 divided by 12. 29,760 divided by 12 on a calculator is 2,480. So the answer is, the rate of change is 2,480. Now what does that mean? Per year, there was an increase of 2,480 bags of Takis being confiscated. So we are going to have a very similar question to this one on the final. Obviously, it's not dealing with Takis, but this is a good example where you have to create your two coordinates and then use those two coordinates to plug it into the slope formula to be able to find the rate of change. And once again, the important part of this one is to first remember that rate of change really means slope. And slope formula is something that we all know how to do. All we need is coordinates. You get them from the year and the amount, the year and the amount. And you get those two coordinates, plug it all in, work out the slope, you're done. So I do want to mention that the final exam is exactly like this practice final. There's 32 questions on this practice final. There's 32 questions on the final. So every single question, I promise you, every single question you see right here is going to be on the final. Not exactly the same, but very similar to it. So if you don't understand one of these, like 29, if you don't understand that, you're not going to understand a question on the final. So please make sure that you study all these questions. If you don't understand the videos and you still need help, ask somebody because you will see it on the final.